So today's topic is dual graph, and I have an example regarding it and self-dual graph. Now coming to the definition of dual graph, if G dash is a multigraph, that is the all the edges start from one point and multiple edges reach to that same end point. It's called multigraph. With R dash and S dash are vertices joined by E dash. Then corresponding to multigraph G is another graph is joined by E. This is called as dual graph. In simple, in G dash the two vertices are connected by E dash. In similar way, in G they are connected by E. So this is called dual graph. And when we will call that dual graph as self-dual graph is if the following conditions are satisfied. Those are the number of regions. These are in G and these are in G dash. The number of regions in G is equal to number of vertices in G dash. Like that, vertices in G is equal to regions in G dash, and edges in G is equal to edges in E dash, and degree sequence of G dash is equal to degree sequence of G. So now let us discuss about one example. So the example is show that the following graph is self-dual graph. To prove self-dual graph, first we should do is to prove it self-dual graph or not. First we should find dual graph of it. Let dual graph be G dash. Okay. Now the given figure is this. This is the original graph G. Now we will assume R1, R2, R3, R4, R5 and outer region is R6. Okay. This consists of both inner and outer regions. So we have named like this. So in the dual graph G dash vertices are R1 dash, R2 dash, R3 dash, R4 dash, R5 dash, R6 dash. We got this from this graph. These are the regions converted into vertices in the dual graph G dash. Now we should mark the points in such a way that these vertices should be arranged properly. Okay. Now we have given the vertices like this. Now the simple logic is see that R1 is in this region and outer region, entire region is R6. So between R1 and this is R6 there is an edge. So we should connect R1 and R6 like this. So similarly we should check, for example, R1 and R2 there is an edge like this. So we should connect R1 and R2. So another one I will tell this R1 is R5, another edge is there. So R1 and R5 should be connected. Similar way all should be connected. So this is our required dual graph. Let us check it is self-dual or not according to these four conditions. So therefore the conditions are satisfied, so it is self-dual.